Hello guys, my name is Nelson Viegas. I'm a high performance trainer, and the subject that I want to bring today, it's one of the muscle hypertrophy pathways, probably the most important one, that is called mechanotransduction. So what means mechanotransduction? So mechanotransduction, like the name is already saying, there is a mechanical stress with the resistance training, and there is a transduction. So there is a response, a chemical response inside your cells to make that muscle grow. So it's not just lifting weights, it's what type of physiological adjustments that you need to force your body to be in for the body to change. Okay, so to create muscle hypertrophy, you need to put your body every day under several physiological stresses that forces it to create new adjustments to respond to those stresses, and give it the proper nutrition and rest for long periods of time, decades, because it's a chronic process, not acute. So training light and soft will not maximize the process of muscle building. Mechanotransduction is still the main factor for muscle hypertrophy, which is doing between 6 to 12 reps. This type of stimulus creates a great muscle breakdown on the cell membrane by mechanoreceptors activation, like titin, costamers, filamin C, and SACs, that stands for stretch activated ion channels, increasing the breakdown of phospholipids that are metabolized by phospholipase A2 and phospholipase C and converted into arachidonic acid, that is metabolized by cyclooxygenase 2, known as COX-2, and converted into prostaglandins, PGE2, that attract neutrophils and macrophages M1 to do the phagocytis and release interleukin-1 beta, interleukin 6, and TNF-alpha. These inflammatory cytokines stimulate satellite cells differentiation, and the creation of new myonucleus. So, make a long story short, when you create stress in your muscle, so the muscles, every cell in your body is made of phospholipids. These phospholipids, when they are under stress, when you activate these mechanoreceptors, what happens is you have some breakdown of those phospholipids, and they are metabolized by 2 enzymes. 3 enzymes, but let's speak just about 2 today. Phospholipase A2 and phospholipase C. So these phospholipases, they convert those phospholipids into arachidonic acid. Arachidonic acid, by the enzyme cyclooxygenase 2, it's converted to prostaglandins. So all these are inflammatory signaling, inflammatory signals. That's why we don't use cyclooxygenase anti-inflammatory medication before workout or after workout. For example, Voltaren, for example, ibuprofen. This type of anti-inflammatories, they inhibit this cyclooxygenase, the 1, the 2, and the 3, but in the muscle is the 2. So inhibiting the cyclooxygenase 2, you are inhibiting the signal. So if you take anti-inflammatories before workout, we know already that will jeopardize the stimulus of the training. So it's not a very smart move to take anti-inflammatory medication before workout or after workout. Another thing that we don't like to use before and after workout is any type of antioxidant, like vitamin C, vitamin E, astaxanthin. This type of antioxidants also blocks another pathway, another stimulus that we call EROS, which is stands for reactive oxygen species. So we produce in our mitochondria a reactive oxygen species. I can make a video about that they are also a very important signal to muscle hypertrophy. Okay, so what happens is when you produce these inflammatory cytokines, you call to the muscle that was trained, these neutrophils and macrophages M1, and they release these inflammatory cytokines like interleukin-1 beta, interleukin 6, and TNF-alpha. So when you release these inflammatory cytokines, so imagine this is a muscle cell. We can call muscle cell or muscle fiber. The muscle cell, the muscle fiber, they don't have one nucleus. They have several myonucleus, okay? So imagine that for every this is just an example, 2 centimeters, you have a myonucleus. Here, around the muscle fiber, we have stem cells or satellite cells. These cells, they are not differentiated, okay? So they are there, like sleeping, in case something happens to one of the cells. So what happens is when this inflammatory signal happens in the muscle, we have the differentiation of those satellite cells. So one satellite cell becomes 2, so differentiates. And when you train, the muscle fiber increases the size on a longitudinal and parallel way, so both ways. So the muscle fiber increases. So when the muscle fiber increases, imagine if the muscle fiber increases, the myonucleus has no domain, because every myonucleus in a muscle cell has what we call myonuclear domain, which that domain, that myonucleus, is control an area. So when the muscle grows, it controls this area, but now there is more muscle here being built, and there is no myonucleus. So these satellite cells, they fuse to the muscle fiber and they donate the myonucleus. So now the cell has more myonucleus, so it can grow in size. So in a parallel way and also in a longitudinal way, okay? We call parallel and in series. So this is how it happens. So we have, at the same time, we have another muscle hypertrophy pathway that we call muscle damage, which is between 1 to 6 reps, especially the eccentric phase emphasis. This type of stimulus creates a huge breakdown on the cell membrane, increasing phospholipids. So they break down the phospholipids and they are metabolized by phospholipase D. So remember what I told you. We have 3 phospholipases. With this stimulus, we activate phospholipase A2, phospholipase C. But if we do heavy workouts and we do 1 to 6 reps and we focus more on the eccentric phase, we activate another phospholipase called phospholipase D. That they convert phosphatidic acid, so the phospholipase D converts the phospholipids in phosphatidic acid, and phosphatidic acid activates mTORC1. So this stimulus creates more sarcomers in series, while concentric phase increases sarcomers in parallel, okay? So parallel is like this, and in series is like this. So make a long story short, muscle hypertrophy has several mechanisms. More reps with a moderate to heavy weight. You can use more heavy weights, or you can use more reps and less weight, okay? That is for another video. I can explain the end factor activation, nuclear factor activated by T cells. We have MAP activation, mitogen activated protein kinase. You have the activation of aquapurinas, which is integrating proteins on the cell, like for example aquapurina 1 and aquapurina 4. So we have several mechanisms that also helps mechanotransduction, but still the science and all the researchers that I work, they still believe, and I also believe, that mechanotransduction is still the main factor. But guys, don't stick with this 6 to 12 for every exercise of your training. If you are a professional, if you do 6, 7 exercises per big muscle, don't just do 6 to 12. Try to do heavier exercise in the beginning of the training, and when you go to the end of the training, try to reduce the weight and increase the number of reps, reduce the time that you rest, to create other type of response in your body. Okay, I hope you guys understood this video. I try to make this video as short as possible for you guys to understand what is the difference between mechanotransduction, what is the difference between the muscle growing in series or growing in parallel. So what is the difference of that, and how can you maximize your trainings without jeopardizing, without creating injuries, without creating any type of we call overreaching and overtraining. So with the time, if you abuse on these heavy workouts, what can happen? You can go to overreaching, which is close to overtraining. Make sure your diet, like I say, that and your sleep, it's on point for you guys, and do this for years, for decades. It's not an acute process. People sometimes they watch studies and they see, oh, muscle protein synthesis. They see MPS, muscle protein synthesis. Oh, if I eat every 5 hours, I increase my muscle protein synthesis. Yes, it's true, but that it's also not the process that you grow the muscle. Muscle protein synthesis is something that happens acute. You need to do that for a long period of time and increase the muscle protein synthesis, but at the same time reduce the muscle protein breakdown. So make sure you activate your ribosomes and you somehow deactivate or reduce the action of your proteasomes, okay? So, but that's for another video. Today I just want to focus on the process of mechanotransduction. I hope you guys understood. Thank you so much. Keep following me. I will make more videos explaining diet, training, everything in a pro level, how we work. I try to not be too much technical, but it's very difficult not to be technical because otherwise you guys don't understand. You just come here, I'll just do 6 to 12. Why? I don't know. Someone told me, I saw a video in YouTube, but why? What is the phospholipase A2? What is the phospholipase C? What is the phospholipase D? What is the arachidonic acid? So it's very important for you guys to understand these physiological adaptations that we do in our training. And then with the proper diet, the proper periodization, you know, and the proper rest and everything together, supplements, everything, you can have the best results. Okay, thank you so much.